Hello. We at Cincinnati Mine Machinery Company would like to show you a short video about the importance of proper tensioning of the dual sprocket conveyor chain on a continuous mine. It is important to note that a chain that is too loose will get impacted by the CLAs, and a chain that is too tight will suffer from an increased wear rate. Proper tension is vitally important to achieving the best chain life. This video will show the chain operating at normal speed and slow motion to allow you to see the differences between a properly tensioned chain and a loose chain. Now that with the conveyor cleaned out and the discharge conveyor flat, level, and in a straight position, jog the chain and notice all the attributes of the chain's operation, that is the startup, the throw off the sprocket, the sound, and the stopping motion. Does the chain coast or abruptly stop? Each specific attribute may help solve a potential problem. Certainly, we must also inspect the entire chain path and the tensioning system to make sure everything is functioning properly. Proper tension is achieved by controlling the slack loop thrown over the foot shaft sprocket. This slack loop must be minimized in order to reduce the possibility of the interference of the chain and the CLAs. Our procedure may differ from the original equipment manufacturers, but the end result will be the same. To check tension, go to the rear of the machine and try to articulate the flight arm. You should have 2 to 4 inches of flight arm articulation on most machines. Note here again in this loose chain, slow motion video, how much the chain throws off the sprocket. With the chain raising this high off the sprocket, the chain is being impacted by the faster moving CLA tips. This loose chain will allow rock to get under the chain, lifting the arm off the coal deck, and then be pulled up into the chain hold downs, causing another impact. These multiple impacts reduce the chain life and can create other situations dealing with the sprocket engagement. Note how this loose chain coasts to a stop and folds over on itself. This much chain slack in the conveyor chain creates the worst scenario for damage to the chain and sprocket to occur during startup. To tension the chain, we must install shims in the take-up system. These shims should be installed by equal amounts on each side to keep the chain centered on the tail roller. Other aspects of the conveying system need to be inspected on a daily basis. Please take time to review the position of the tail roller within the slide length and to ensure that the take-up device can properly work. Once the shims have been installed, check the flight articulation again to ensure you have the required 2 to 4 inches of chain movement. After the chain is tensioned evenly, start the conveyor again and watch the chain and slack loop. If it appears good at this time, then swing the conveyor to the maximum extent in both directions. If the chain is not hitting the CLAs, then stop the chain and restart it while keeping the conveyor swung in its maximum position. Check and see what the slack loop looked like in this position, and you must evaluate if more shims are needed to keep the chain out of the CLAs with the conveyor swung. Be sure to check the entire chain path to look for bent hold downs or damaged springboards and to ensure that the return deck chain guides are in place. This properly tensioned chain coasts to a stop and will minimize the wear in the chain links and provide the best life. Look at the condition of the tail roller, the sliding pans, and the coil springs and shims. The coil springs must be able to work. They can't be packed off with gob. The springs are an important part of the system in absorbing the shock and controlling tension. The sliding pan must be able to move freely and the tail roller work properly. Shim amounts from side to side must be equal. Look at the conveyor swinging section and check if the discharge conveyor needs shimmed. A sagging conveyor obstructs the conveyor path and generates noise and induces a shock load into the chain. Check the entire conveyor path. Are there hold downs missing, or do the hold downs show indentation marks from the chain? If the mining conditions build muck or gob in the conveyor path, the hold downs can be very detrimental to the chain. Check for loose wearing strips or chain strippers if the machine is so equipped. 2 sure signs of an over-tensioned chain would be that it would feel rock solid when you grabbed the flight and tried to articulate or rotate them. Secondly, the chain would not coast when it stopped. It stopped quickly on the sprocket. Note that over-tensioning the chain also puts an increased bending load on the foot shaft and the related assembly components and wears the chain pins and links quicker. The benefit of proper tensioning is that it will provide better life for the chain. Thank you for watching this video on the tensioning procedure of our DA3502A dual sprocket conveyor chain.